But right now, let's get to problem of the day. And problem of the day is all about Hallie. Hallie takes a number plus 4. Then she multiplies that sum by 5. She subtracts 10, and the result is 45. What is the original number? Well, that's a kind of a story, isn't it, folks? Hallie takes a number plus 4, that tells me something, and multiplies that sum by 5, that tells me something else. Now we're going to subtract 10, and let's get a result of 45. Let's talk about this problem. Let's see what's going on here. This is just basically reading and working the operations. Now, some of you are going like, do we have to do algebra? We're going to do algebra, you know that. But you could do this basically in your mind if you work backwards. And let's just play that game, all right? Just play it through to see what's going on with the number. Then we're going to put it to the algebra moments, and you're going to say, oh, this is the exact same thing we did. We worked it backwards in our head, because that's what most of you will do to get to the final answer, which is a good option. Very good option. So it said, first of all, she subtracted 10 and got 45 as a result. So to reverse that process, let's go backwards. That means we're going to add this 10 back here to 55, which tells me something. It tells me this result over here is going to give me 55. Let's work backwards a little bit more. We have multiplied by 5. So how do we undo multiplication? We divide by 5. We're back to what? 55 divided by 5? We get 11. And you know, I haven't written a thing on the page yet, have I? You're going like, Ernie, you're talking to us a lot. Yeah, I am. And we've got what? 4 and a number that are going to give me that 11. Answer should be 7. Mark on Facebook got 7. I don't know if he did it this way or if he worked it out algebraically, but you know, he was right on that. And some others of you may be checking us out on Facebook and seeing if you got that problem of the day right or if you've gotten started on it. But the number 7. Now you say, oh, and you're going to make us do algebra? Yeah, I'm going to make you do algebra. Okay, let's look at it here. And actually, it's a good way to learn how to do those algebra operations, all right, and work it through. So we start off with a number. I don't know what it is. Hallie's number, all right? So here we go. Hallie has a number, and it's in. We don't know what it is, but she does. And we're going to find out what her secret number is right here. She's going to take that number, and according to the instructions, or what she's told us, we're going to add 4. So we got n plus 4. That was easy to look at. And we're going to multiply that sum. The sum means, let's put a little parenthesis around there. Put a 5 in front. Whew. Keeps going, doesn't it? And that's where we are at this point after the first sentence, all right? What's happened here? We took the number plus 4. That was easy. And multiply that sum. That sum indicates we want to put a parenthesis around n plus 4. And you know what's going to happen here, my friends? What's going to happen? Got to distribute in a minute. But hang on. We've still got to finish the problem. So here comes, she subtracts 10. Put a big minus 10 right there. Boom. And the results, oh, that makes an equals, doesn't it? The result is, and we got 45. Now, time to play with it. Remember what I said. Let's work it backwards, so to speak. But let's also work it forward a little bit just to begin with. Let's go with this distributive property and kick it right into gear. All right, we're going to say 5 times. We're going to say that parenthesis n plus 4. You got it? It's going to be 5n plus 20. Now we subtract 10. And goodness sakes, we're going to have 45. Now I jumped a little bit with the distributive property. So you said, well, Ernie, could you go ahead and do the plus 10 like you said in the earlier part? I sure could. And then I would have had to divide by 5, and I could add in plus 4. That's another way of doing it. If you all learned something from me, I hope you do, that sometimes there's more than one way to get through to the final value when you work backwards with these things. But for right now, let's continue on with the way I have set us here. Like it or not, we're on our road here. We're on the path. So let's put that 20 and that 10 together. That's going to give us 5n plus 10 equaling to 45. Now we'll move the plus 10. We will subtract it out. That's going to leave me with 5n over here on the left-hand side. That's the left-hand side. That's a minus 10 for those of you just turning in to us here, tuning in. We are going to give us 35 over here. And the good news is that comes out even. I always like things when they come out even. Looks like her number is 7. Now let's check and see if that makes sense when we plug that 7 back into the problem. Not necessarily the equation here, but does it make sense in your problem? She takes her number, 7, adds 4, we get 11. Now multiply that 11 by 5. You're going to be up to 55. Subtract your 10, 45. Well, that's what we're supposed to end up with, isn't it? So once again, add it, you get 11. Multiply, get 55. Subtract that 10, and you're back to 45, which is where you wanted to start with. Now, real quickly, I mentioned something to the effect of when we were setting this thing up, where you're going to go ahead and put 5 times n plus 4 minus 10 equaling 45. What I want to do is let's go ahead and add the 10 to begin with. You say, can you do that? Sure, we can do that. It's basically unattached. It's not attached to this parenthesis. The 5 is attached to the parenthesis, but the minus 10 is kind of hanging on by its own. So we can do that, and that would give us 5 times n plus 4 equaling to 55. Some of you are going, where are you going to distribute? Well, I'm not. We're going to divide by 5 because that's hooked in by multiplication. So let's divide 5. Divide on the left side, do it to the right side. Division this time, property of equality. Knock it out of there. Say goodbye to those 5s. Actually, say goodbye to a lot of 5s here because that's going to become 11. We got n plus 4. And you know what? You subtract your 4. My goodness, we got n equals 7. Same value, we know it works because we've already changed it through. So this is another option, working it backwards in this respect, or go ahead and do it a little forward and then going backwards with your distributive property, and if you like terms going for you, then just take a simple equation. Either way, guess what? You come up with n equals 7. And like I said, you can even do it mentally in your head if you just work back with your numbers there. But remember, folks, algebra, it's simply the language of our numbers. It involves our addition, subtraction, multiplication, and division. And this pretty much had just about everything in it except a division, but we had to reverse the process with the multiplication. So we actually did use some division. So use your 4 operations. It's all about the numbers here, but don't let them get you scared. Once you set up the language, play with it. All right? That's our problem of the day today.